Now we are going to discuss the method of three bearings of same object. This method is also known as three-point bearing. And when you solve a question using this method, the diagram will look something like this. So let's see now what all data is provided to us in these type of questions. They will provide us with three true bearings of a object. They will also give us the time intervals or distances run between the three observations. They will give us the direction of wind and leeway if there is any. And they will give us three data items out of compass course steered, engine speed, direction of the current, and rate of the current. So out of these four data items, any three could be provided to us in the question. This is the data which is available. And what we are required to find is the course made good by the ship and the position of the ship at all the three times. Let's now move on to the chart and see how this question is done. We have the chart in front of us now. Now, first of all, we will draw the three given bearings to us. Let's name the object as O. You can see we have Hook Head Lighthouse at this particular location on the chart. That is our object O. This is the first bearing line. You can see it on the chart drawn. Let's name this as OX, and this bearing was taken at 1000 hours. Let's plot the second bearing line now. This is the second bearing line on the chart. Let's name it as OY, and this bearing was taken at 1025. Let's plot the third bearing line now. This is the third bearing line on the chart. Let's name it OZ, and this third bearing was obtained at 1100 hours. Now we have to calculate the ratio of two time intervals, or in case the distances are given, then the ratio of the distances between the first and second bearing, that is OX and OY, and between the second and third bearing, which is OY and OZ. Now in this question, the first bearing was taken at 1000, the second was taken at 1025. So the time interval between first and second bearing is 25 minutes. The time interval between the second and third bearing is 35 minutes. If we take a ratio between 25 and 35, we get a ratio of 5:7. Now we have to draw a line through object O, in this case the Hook Head Lighthouse. Now this line should be drawn in such a way that it is clear of all the three bearings. And also make sure that all the three bearing lines are on one side of this line. So let's draw a line. You can see a line drawn from point O, passing from point O. As you can see, this line is clear of all the three bearings, and all the three bearing lines lie on one side of this line. Now, in the next step, we have to measure convenient distances on this line. These distances should be marked or measured on either side of our object O. We have to make sure that the distances are marked in the same ratio, which is 5:7. So let's mark these two distances from point O. Now I keep my compass on object O. I open it up equal to 5 nautical miles and I draw an arc. This arc cuts the line at point A. This point A is 5 miles from the lighthouse O. Now let's do the same thing on the other side, on the side of the third bearing. So I keep my compass on object O, open it up equal to 7 nautical miles and make a arc cutting this line. This arc cuts the line at point B. So I have point A and point B marked on the line which I drew passing from the lighthouse.
Beta, up to here, any doubt in the procedure?
No, sir.
So the line we draw from O, is there any direction to it, or it is just a line where three bearings are on one side?
Okay. Beta, some of the books tell you to draw this line perpendicular to the middle bearing. Okay, but it is not necessary, it is not compulsory that it should be perpendicular. You can draw any line passing from point O. We have to just keep in mind that all the three bearings lie on one side of that particular line and our plot will be correct. Okay. The only advantage of drawing it perpendicular to the middle bearing is that the diagram looks very crisp and clear. That is the only advantage. Otherwise, you can draw any line passing from O. Just keep in mind that all the three bearings should lie on one side of it. Any direction can be drawn.
Got it, sir. Got it, sir.
Okay. और बेटा
सर एक तो पहली वाली स्लाइड दिखाइएगा
इससे पहले वाली
यस सर
ओके दिस वन बेटा
हाँ यस सर ओके सर ओके
okay, all right, so shall we move ahead now? We mark these points A and point B.
Now, once we have these points A and B marked on the line, we have to now draw lines passing from A and B, which are parallel to our middle bearing. Our middle bearing is OY. So we will draw a line passing from A parallel to OY. You can see this line on the screen now. This line cuts my first bearing, that is OX. Now you can see the second line passing from point B and parallel to OY, our middle bearing. Now this line cuts our third bearing line, that is OZ. Now the point where the parallel line passing from A cuts my first bearing line OX, let's name that point as C. You can see that point on the screen now. And the point where the line drawn from Bravo cuts my third bearing line, that is OZ, let's name that point as D. You can see D point also on the screen now. Now let's join these 2 points, C and D. This line CD gives me my course made good. Important thing to note here is that this line gives us the direction of the course made good, but this line does not give us the distance made good between the first bearing and the third bearing. Let's mark it with 2 arrows. That is the symbol for course made good vector. Now from the compass course, which is usually given to us in the question, we apply the deviation and variation. Once we apply deviation and variation to the compass course, we obtain the true course steered. If there is wind and leeway given to us, we will apply the wind as well as the leeway angle, and we will find our leeway track. The leeway track which we have found will be used in making the course, speed and current vector triangle. We will make this triangle starting from point C. So let's first draw our leeway track. You can see the blue color vector on the screen now, which represents the leeway track. Let's mark it with a single arrow. That's the symbol for leeway track or course steered. Now the second item which is usually given to us is the current. So we will be marking the current vector now. This leeway track vector which we have made, the blue color vector, we have to make sure that the length of this vector is corresponding to the distance traveled by the ship between the first bearing line and the third bearing line. So let's call the point where our leeway track ends as point E. You can see point E on the chart now. Now from this point E, I draw my current vector. You can see the red color current vector on the screen. Let's mark it with 3 arrows. And wherever this current vector meets the course made good line, let's mark that point as F. Now CEF, Charlie Echo Foxtrot, is our course, speed and current vector triangle for the duration of time between the first bearing OX and the last bearing OZ.
Beta, any doubt up to here in the procedure?
So the extreme times which are given are 10 o'clock and 11 o'clock. So that's why we are making 1 hour triangle.
That's right, beta. It will be a 1 hour triangle in this case.
Okay, okay.
So जो ट्रायंगल लेंगे हम वो फर्स्ट पॉइंट बेयरिंग और लास्ट पॉइंट बेयरिंग के बीच का लेंगे डिस्टेंस टाइमिंग
For this triangle, beta, CEF.
यस सर
Right, beta. This CEF triangle will be exactly for that duration. What is the duration between first and last bearing? So उतने ही टाइम के लिए हमने इस ट्रायंगल को बनाना है. Let us say अगर ड्यूरेशन 1.5 आवर्स की होती तो हमारी CEF ट्रायंगल भी 1.5 आवर के लिए बनती. अगर ड्यूरेशन 2 आवर्स की होती तो हमारी ट्रायंगल 2 आवर्स के लिए बनती. This triangle has to be for the same duration between the first bearing and the last bearing. ओके बेटा, चलें आगे.
ये EF सीधा करंट वेक्टर है ना 1 घंटे के लिए बस.
EF is the current vector, beta. E to F is the current vector.
And sir, CE is the course and speed of the vessel given in the question, right?
That's right. That is the CTS and engine distance in this 1 hour duration. It is given to us in the question. Okay, let's proceed ahead then.
Now we can measure CF side of this triangle, Charlie Foxtrot. This side CF is the distance made good by the ship in this time interval. That is the time interval between the first bearing and the third bearing. When we have this distance made good available to us, we can calculate the speed made good by the ship. Now let's see how do we find out our positions. Now for finding the position, we transfer our first bearing line, that is OX, through point F. So let's pick up our parallel ruler, align it with the first bearing line OX and transfer it to pass through Foxtrot or F point. So I have transferred my first bearing line through F now. Now you can see this bearing line, transferred bearing line on the chart. Let's mark it with 2 arrows on both the sides. This is the symbol for a transferred position line. Now this transferred position line cuts my third bearing, that is OZ, at a certain point. Let's call that point as R. You can see that point on the chart now. We have point R. Now from this point R, we draw our course made good in the reverse direction from R backwards. Now once you draw this course made good from point R in the reverse direction, you will see it will cut our first bearing line OX and the second bearing line OY. Let's name the point where it cuts the first bearing line as P. You can see this P point on the chart. And let's name the point where it cuts the second bearing line as Q. You can see Q point also on the chart now. These three positions which you see, P, Q, R, are our positions at the three given bearings. A position is represented by a dot and a circle around it. So let's make these circles at all these three positions. So you can see now we have all the three positions known to us from the plot. We have the course made good also known to us. So this is the 3-point bearing method or three bearings of the same object method.
सर जो ये वेक्टर है इससे डिस्टेंस नहीं है, सिर्फ डायरेक्शन वेक्टर है ना?
Beta, this is only the direction vector. They only give us the direction of the current. So we draw this direction vector. The magnitude comes automatically wherever it touches the course made good line. That is the F point, and we can measure the drift of the current from here.
और सर सीई जो है वो 1 आवर का बनाएंगे?
Beta, whatever is the duration between the first and last bearing.
ओके सर.
क्योंकि आप देखो हमें फर्स्ट पीएल को ट्रांसफर करना है ना टू द टाइम ऑफ द थर्ड पीएल, सो दिस ट्रायंगल हैज टू बी फॉर द सेम ड्यूरेशन.
ओके सर. तो मतलब एक तरीके से हमारा जैसे 070 हुआ सर, ये अपना CD जो है 070 हुआ और 3 डिग्री का लीवे है, तो 067 ले लिया है उसको CE को, करेक्ट?
ओके, जो CD था बेटा वो तो हमें मिला था बाय मेकिंग द 3-point bearing plot, and CE is given to us in the question. Whatever is the CTS, it is given to us in the question, so we plot it.
ओके सर.
सर जो क्वेश्चन में दिया उसमें लीवे लगा के फिर प्लॉट किया कि ऐसे ही किया?
बेटा अगर लीवे दिया हुआ है तो देन ऑफ कोर्स वी विल अप्लाई द लीवे एंड वी विल प्लॉट द इफेक्टिव कोर्स हियर. So if leeway is not there, then CTS is plotted directly. Okay, so if this is clear, then we are done with the 3-point bearing method.